All right, guys. Let's talk about something here real quick that is maybe of interest to you. Powerball. You know what Powerball is, right? Lottery. Okay. So Powerball, the way it works. Okay. There are numbers numbered 1 through. Unfortunately. Okay. So those are the. So you're gonna have five spots for those numbers. Okay. Then there is the Powerball, so which is like a multiplier of your winnings. It's one number from 1 through 26. Okay. So let's talk about how we win the Powerball. Okay. Now I think there's a total of, you go on their website, there's a total of 9 different ways you can win a payout. Okay. But there's only one way that you win the jackpot. Okay. So like if I match the 5 numbers, but I don't get the red number, I don't get the Powerball, I still win money. I think I win like $1 million. If you make like 4 of those numbers, you get a payout. Okay. But if I want the entire payout all to myself, okay, I got to match those 5. No, I guess not all to myself, because some tickets you can have multiple winners, and then you share it. But I need to match my 5 numbers with those in any order, and then I need to match this red one. So because there's any order, and this is said with what we call without replacement, what we do is we think about this idea of how many numbers are 1 through 69. How many numbers are there? Okay. So I've got 69 numbers that can be chosen for the first number on my ticket. Does that make sense? Okay. Now, if I choose like the number 12, then 12 can't go here. Does that make sense? It can't go anywhere else in the list. So the next number, I only have 68 things can go there. So how many can go here then? 67, and how many here? 66, and how many here? 65. Okay. So now what this is called, okay, is a combination, and we'll talk about this later on in more detail. But let's just give me let's say this, even though these are the amounts of let's do it this way. So let's say this number is 12. Let's say this one was 17, 3, 28, and 61. Okay? That is a winning ticket for those 5 spots. Does that make sense? But 17, like if I go 17, 12, 28, 3, 61, if this is what gets pulled out in the drawing, but this is what I have, I still win. Does that make sense? So you don't need to match them in order. If you had to match them in order, the probability of winning is even more minute than what it currently is. Okay? So now, so this is the fundamental counting principle we talked about the other day. 69 things to go in the first spot, 68 in the second, 67 in the third. How many can go in this spot? 26. Okay? So let's real quick take and multiply this out. Yes? Uh-huh. Uh-huh. Yep. So if we multiply all those together, we get that number right there, which is 3.506416056 times 10 to the 10th. Okay, so 10 to the 9th is referring to a billion. Okay, so this is like 35 billion. Does that make sense? Okay. Now, that's if that 35 billion. So if I have the one lottery ticket that matches, I have a 1 chance out of 35 billion to win. Now, to put that in just perspective, and I'll talk about this in a little bit more detail, because that's not the probability of winning the lottery, okay, or winning the Powerball. But to put that in perspective, none of you have been alive for a billion seconds yet. I would argue that probably none of you have been alive for maybe half a billion, okay? I'm the only one in the room been alive for a billion seconds and just recently passed that threshold, okay? I think it's like 31, 32, okay? 16, 17, okay? And we can spend some time just multiplying the seconds together, but a billion seconds is over 30 years long, okay? So 35 billion, you got 1 out of 30. Think about how many seconds that would be. You got 1 out of 35 billion chances to win the lottery. Now, what that 35 billion right there is talking about is if I match them in order. Does that make sense? Okay. Now, what we had to do, so in order to and we'll talk about this in an upcoming section, in order to count those, so I want those to be counted one time, okay? And there's actually, so what I could do is say, okay, what I've done here is I've moved the 12 to the second spot here. And then I'm going to take, okay, let's go 17, and then 28, 12, 3, 61. Let's go 17, 28, 3, 12, 61. And let's go 17, 28, 3, 61, 12. All of those need to be counted and equated to just one winning ticket. Does that make sense? And that's by moving just the 12 through and getting those 5. Okay? Then what I would do is I'll take the 17 and move it through, and there's going to be 5 more of those. Okay? In order to do that, there's actually 120. There's 120 different orders that we need to remove out, basically. Okay, and they're basically duplicates. These are duplicates. These 5 all win. Okay, so I want those 5 to be counted as just one. So what we do is we divide them out. So let me go back to Desmos. Okay, and the way we do is, and we'll talk about in more detail, it's 5 factorial, which means 5 times 4 times 3 times 2 times 1. And we'll talk about that next week and why that's the case. But if I take these two numbers, I'm just going to call this A. I'm going to take A divided by 120, and I get that number right there. Okay? Now that number is 292,201,338. That is the sample space for you winning the lottery. If you buy one lottery ticket, okay, that is the winning lottery ticket, you have a 1 chance out of 292,201,338 probability of winning the lottery. Does that make sense? Okay. Pretty low, correct? I believe, and I double checked this, but I believe that you have, I think the chance of getting struck by lightning is like 2 million. Okay, so this is saying that you've got 1 in 15,300 chances of getting struck by lightning. Okay, we have a 1 in 292 million chances of winning the lottery. Okay, so you have a much higher chance of getting struck by lightning than you do winning the lottery. Okay. While you're winning the lottery? I don't know. I'll see if Google has an answer.